Everyone's on their way in. So hi, I'm Jeff Weinstein, and this is my partner, Steve Pike, and we're here to talk to you about our computer science senior project, which we're calling AtLongLat. So AtLongLat is an online service that improves the way that users are able to share their geographic location over the internet to other online services. So today, we think it's too complicated, too insecure, and doesn't have the privacy settings that one might want when they want to be able to share where they are over the internet. And sometimes it just feels just plain creepy, and we want to give you a new way of being able to broadcast that location. So for consumers, we've built tools that give them access to who controls their location data, when it's available, and with what privacy settings. Now for developers who want to make online applications that want to be able to use a user's location, we've built a platform that allows them an easy way to query where the user is without any knowledge of what device it came from or what service it's running on. So today I'm going to run through some of the problems that we've noticed in how people share their location online. Then I'm going to go over our technical approach to how we solve these problems. We'll review our architecture. I'm going to turn it over to Steve to do a demonstration, and then we'll take your questions. To get started, so for consumers, there are many interesting web applications online which leverage a user's location. For example, you can go on Flickr and find photos nearby where you are. You can read messages from your friends in a local area on Twitter. You can even keep track of friends and family on Google Latitude. These are some just example popular services which require you to know where a user is. Now, if a user wants to be able to use one of these services, he or she needs to be able to send their location data directly to the online service. Now, this is fine, but if you want to go and manage your access rights or change your privacy settings, you're going to need to do so for each application. You can imagine if you use a dozen of these services or more, this could take a very long time. Also, it might not have the privacy settings that you want. So for example, if you don't want to be seen on the weekends on a particular service, but Google doesn't allow you to do that, or you don't want to be seen at night, but Yahoo doesn't have those privacy settings, you might not trust their service. Can we give you new ways of being able to control your access? Also, these great online applications, consumers would like them to be able to run on any type of device. Now, imagine a tablet PC. It might not have internal hardware that's able to recognize where it is, but you have a cell phone in your pocket that has GPS. Is there a way of leveraging that data that's available on your cell phone to use on other platforms that don't have location awareness? For developers who want to write these services, let's say I want to make a new application. I have to query my location, the user location from many different people, each of whom might have a different type of device. So that means I need to write an application for each phone or device or source location service. And that means that I'm going to have to do a new application for each new type of device. But as a developer, I just want to have the user's location independent of how it was determined. Also, since location is such a sensitive piece of data, developers need to make robust privacy settings so that consumers trust the service. You need to make sure that they're not doing bad things with your data and not sharing it with other people. So developer needs to re-implement privacy settings for each application that they make. This is a very cumbersome process, quite difficult and time intensive. Wouldn't it be great if we could abstract away the privacy settings so that developers don't need to do this re-implementation each time? So these problems served as the motivation for our project. We noticed that consumers are interested in broadcasting their location as long as they can do it securely and with their own privacy settings. They also want to be able to use any type of device and aggregate that location data to be able to provide to online services. Lastly, we want to make a really easy way for consumers to be able to manage their privacy and access. Who has access to my location, where and when? And let's do it in a centralized way so you don't have to do it on 15 different systems. For developers, they want a standard way to be able to query a user location independent of how it was determined, as well as have privacy settings abstracted away from their application so they don't have to re-implement them each time. And lastly, developers would love if their online services could run on any type of platform, independent of if it has location awareness. So for our technical approach, AtLongLat is a server application which brokers between a user's sources and their online applications. So internally, it's broken into 4 layers. The first layer is our source interface layer. This communicates with each type of device and allows source readings to be sent to our system. We use an open standard protocol to make sure that user source is registered and authenticated with our site It's called OAuth. It allows us to make sure that a location that's coming in from a device is tied to a specific user. Also, we accept location from any type of device that's able to make URL calls over the internet, which means that any device that is capable of accessing our server can send location updates. So now once we have source readings flowing in from different devices onto our system, they're stored on our server. We have an aggregation algorithm layer which will take many source readings from a user and produce the single best estimate of the user's location. Now we do this, we have a plugin architecture which allows us to run different type of algorithms to take many source readings and produce this best estimate. Currently, we're using just a very simple one where we take the last reading, but we think this is an open research question in algorithm research for being able to find a best location of the user. The aggregation layer is also responsible of taking a latitude and longitude reading and being able to parse what city it's from, what state it's from, what country it's from, along with the address. So now that we have a specific location determined for the user, we have the privacy layer to protect it. The user can change who has access, which applications have access to my data, as well as what level, what granularity the location is available for. For example, I only want to be seen at a city level or a state level, or for some applications, I like them to have my exact location. We can tweak this on our privacy layer. The privacy layer also allows users to have different types of settings for maybe all of applications or specific ones for different applications. Lastly, our application interface layer communicates with online services that want to request a user's location. Again, we use the OAuth protocol to ensure that applications are tied to a specific user, and so we know that the request is secure. We accept location requests over HTTP, which means that any web service that's online now has access to a user's location independent of if it has location awareness. So this is how we have a tablet PC that's on the internet, doesn't have location awareness, but is now able to find where the user is. And lastly, the privacy has been abstracted away from the developer. So now the developer does not need to do his or her own robust privacy controls. He or she can just inherit the privacy that the user has set before the location is returned. This is because the location first passes through our privacy layer before it's sent back to the online service. So here's our architecture. We have many sources. You might have different types of devices on you. And they send in source readings to our service. They're stored on our server. We have our aggregator that takes the many source readings and produces the best estimate of where you are. Now, when an application wants to know where the user is, the request is first filtered through the privacy layer, and then only if the user has granted that application access or whatever privacy settings, that's what's returned to the application. So I'm going to turn it over to Steve, who's going to show us a live demonstration of our service running live, as well as two sample applications.
OK, thanks, Jeff. I'm now going to take us through a live demo of the AtLongLat service. I'll show you the web portal that a user sees when he logs into our service. I'll then show you the source interface layer. I'll use this iPod Touch device to send a source reading into our system. We'll then protect that reading with our flexible privacy controls before exposing it with our application layer through an example application we wrote that syncs the user's @LongLat location with his Twitter profile, Twitter being a microblogging service that lets you post what you're doing. So to begin, this is the web portal that our demo user sees when he first logs into @LongLat. You'll note that we've placed our user in Seattle to start this demo, and that he has a number of applications and sources registered. One of these sources is an iPod or iPhone application. You can see on the screen behind me the native iPhone interface that I'll be demoing here. OK? When I hit the send key here, it's going to ask me if I want to share my location with the service. And when I allow this to happen, all right, we can go now back to the web portal. Oh, wait, hold on. Refresh that. OK, sorry, the Wi-Fi flaked out. So we sent a source reading from this device up into AtLongLat. We see that we've now moved this user up to Philadelphia. OK, so this is good. But it's only really interesting if we can now broadcast this location up to our third-party application. To demo this, I'm going to show you what we call the AtLongLat Twitter updater. This is a third-party application that only communicates with our AtLongLat service via our third-party API. So the first thing that I want to show you is how a user can authorize an application to access his AtLongLat credentials. We use this OAuth handshake protocol that Jeff briefly mentioned. This allows a user to authorize access to his account without ever exposing his login credentials to a third-party service. So to do this, our user will click that he wants to link his service with AtLongLat. We will be redirected to our AtLongLat server. The user is only logged in on our server and makes an approval here. We're now redirected back to this third-party application on which we'll now be able to access the user's information from AtLongLat. OK, so now we're back to our third-party application. We see that we can access the location information that we just sent in. And OK, so the next thing I want to do is link our Twitter account. Twitter also implements the OAuth API. OK, so here I'm linking our demo user with this Twitter account that's running on the Twitter service. OK, so this is good, but we really want to protect this location information with privacy controls. So right now, our external AtLongLat Twitter updater is seeing exactly where our demo user is. But maybe our demo user is going on vacation after graduation and only wants this service to see what country he's in while he travels Europe for the next month. We can do this with our privacy controls with AtLongLat. So if we go into our privacy pane here, users can set on a global basis for affecting all applications, granularity controls, whether these applications can see what state, country, exactly where I am. We can also set on a per application level granularity and what we call date and time ranges. So I can say application A should only see where I am on the weekends, or application B should not see where I am on Friday nights. In our case, we're going to say that the Twitter AtLongLat updater can only see what country I'm in for the next month. I already have a range set up. I'm going to set it active here. And now when we return to this third-party application, it's going to make the exact same API request to AtLongLat. But this time, it only returned back what country our user was in. We think this is a powerful kind of privacy abstraction. The developer didn't need to know anything about privacy controls. The consumer sent exactly what he wanted to this third party. So now when we update our Twitter location, we can go to our AtLongLat Twitter account, and we'll see that this user's location was shifted to the USA. So we think this shows the real-world flow of information from a device up to our service and then out to an external party while being constrained by privacy controls.
Thanks, Steve. So we think we've identified some large problems in the way that location is currently broadcast over the internet and created a brokering service between users and their applications that gives users back the privacy controls and the access management that they need. Now, developers do not need to re-implement privacy controls since they only get back what the user has specifically allowed. Now, online services can also run on devices that might not have location awareness, and developers do not need to worry about what the way that the location was determined. So we think we've come up with a new approach for how location could be shared over the internet, and we'd love to take your questions. Yes. Yes. The question is how we're going to make money off this. Well, we can jump to that. This type of service could be used by any of the large companies that want to do cloud services around location. So you can imagine firms like Google or Yahoo or Microsoft that want a way for people to aggregate their many location services or their devices. This is the type of firm that'd be more interested in that. So I don't think there's we haven't considered direct monetization techniques, but we think this is a really important way for users to be able to use great online services. We don't plan on advertising, no. We have an iPhone app. It has not hit the App Store, but we used it as a demonstration. Yeah, that's one way we could go about it. Yes?
Twitter challenge. But when you sent that with your device, what was it communicating with? You were using your phone.
Right. So We wrote a native iPhone application just as an example of our source interface layer. It uses the OAuth protocol. It's a handshaking mechanism that ties this specific device to an account. It then sends a request over the internet, over HTTP. It's signed, and it's sent to our server. Our server then records that as that user's
So the flow goes from real-world devices over the internet to our service. And then when applications want to know where a user is, they again make another internet call to us. So the process, this might happen 5 minutes ago, but Twitter gets updated 3 hours from now. We serve as the intermediary between these two layers.
So the phone was sending it to the internet,
Right. The phone was sending it over the internet to our server running on the web.
Yes.
Thank you very much.
Oh, excuse me, one more. Yeah, one more.
Where do you see AtLongLat being used as a statistical analysis?
The question is, how can we imagine our service being used as a statistical analysis tool? It's actually quite interesting. You can imagine situations where if we had lots of user data, we could look at patterns of crowds and other sources since we have location data flowing through us. But that being said, we're sort of trying to brand ourselves as a way of being secure and making sure that privacy is being used. So there's sort of two different types of ways we could go with it. Thank you very much.